Hello, this is Mrs. Pullen for Algebra 2. In this video, I am going over additional problems from the Unit 2 review sheet. We're going to start off with example 14. I'm asked to solve an equation for all values of x, and I notice it's a radical equation because I have a variable under a radical. So the first thing I'm going to do is isolate the radical by adding 6 to both sides. When I do that, I get 8x minus 39 is equal to positive 3. I'm then going to square both sides of the equation, and when I do that, I get 8x minus 39 is equal to 9. When you square a radical, it undoes the operation, and so you're just left with the radicand. It's a linear equation. I know it's linear because I don't have an x squared term, so the next thing I'm going to do is add 39 to both sides of the equation. I get 8x is equal to 48. I divide both sides of the equation by 8, and I get x is equal to 6. It's really important with radical equations to check your answers. If you have time, all equations should be checked, but it's imperative in radical equations. And that's because sometimes you end up with extraneous roots based on, due to the technique that we use. So this becomes square root of 48 minus 39, which is simply 9. So the left-hand side becomes 3 minus 6, or negative 3, and negative 3 is equal to negative 3. So make sure you're not putting in the negative 3 as your solution, but the 6, because sometimes people accidentally put this as opposed to the actual x value. You could have also checked in the graphing calculator. If you use GeoGebra to do that, you would enter the function name. If you enter the square root of 8x minus 39 minus 6, it automatically puts in the function notation, and then I would just go f parentheses, hopefully that will work with a capital, and then negative, I need the negative sign 3. I need the 6. And hit enter, and notice it gives you, I am not quite sure why it did that. Let's try this again with the normal keypad. It should be f parentheses 6, and you see it gives you a negative 3. It made a difference, obviously, when I used the capital, so that's new for me. So just be careful you put the lowercase f for the function name. And again, we see that both sides of the equation are negative 3. Okay, so now let's go to the second example. So we have a radical equation. This is level 2. So the first thing I'm going to do is rewrite it so it's easy for me and the reader to see what's going on. My radical is isolated. I then square both sides of the equation. The left-hand side simply becomes 41 minus 5x, and for the right-hand side, you're going to rewrite it as x minus 7 times x minus 7. I then double distribute. X times x is x squared. X times negative 7x is negative 7. Negative 7 times x is negative 7x, and negative 7 times negative 7 is positive 49. I combine like terms on the same side of the equal sign. This becomes x squared minus 14x plus 49. I have a quadratic equation. I know this because I have an x squared term on the right-hand side. This is not in standard form, so to put it in standard form, I'm subtracting 4x and adding 5x to both sides of the equation. When I do this, my left-hand side becomes 0, and the equation becomes x squared minus 9x. 49 minus 41 is 8. I then factor, and I get x minus 8 times x minus 1. You set each linear factor each equal to 0, and you solve, and you get a solution of 8 and a solution of 1. You need to check both the answers, and I'm going to check 8 first. And I'm going to check by hand. But again, you can use the graphing calculator. So this becomes 41 minus 40, or 1. Is it equal to 8 minus 7 of 1? And it does. So we know the 8 checks. And now we're going to check x equals 1. Is it equal to 1 minus 7? This becomes 41 minus 5, and 41 minus 5 is 36. Is it equal to negative 6? And be careful here. This is not an incomplete quadratic equation. It's just the positive square root of 36, which is 6. If it was x squared is equal to 36, you would take the square root of both sides of the equation and get plus or minus. But that's not what this is. This is just asking for the positive square root of 36. This does not equal, so that means x equals 1 is an extraneous root, and you reject it. So I have only one solution of positive 8. Remember, you're not putting the 1 in there. That was just showing the two sides of the equation are equal. You're putting the 8. If you want to check in the calculator, there are multiple ways of doing it. Again, I pre-entered both sides of the equation, and I'm going to first check 8, so I do f of 8. And I get 1, and now I do g of 8, and I get 1, so that works. And now I want to check the other solution of positive 1, so f of 1 is 6, and g of 1, notice I had to use the lowercase, is negative 6. Those two are not equal, so that is not a solution. So that's how you algebraically solve for radical equations.